Hello class, welcome to this video on the EOC review, part 4. So let's go ahead and continue. So GR 3.3, use coordinate geometry to solve math and real world problems involving lines, circles, tangents, and quads. Alright, so number 1, the line x plus 2y is tangent to a circle whose center is located at 2, -1. Find the tangent point and a second tangent point of a line with the same slope as the given. Alright, so first off, I'm going to go ahead and draw a circle over here. And so let's say we know that the center of the circle is 2, -1, right? So that's the center of the circle. And let's say this is a tangent point on that circle, and this is a tangent line. And let's call this tangent line x plus, well, that's what the equation of the line they gave us. So x plus 2y equals 10. Now, first off, we want to notice that the radius is perpendicular to that tangent line, okay? And so in order to get the radius, we need to know the slope of the tangent line, and then we can figure out what the slope of the radius line is going to be, okay? So I'm going to call this line T, capital T, and I'm going to call this radius line R, okay? So again, like I said, the radius has to be perpendicular to the line T there, the tangent line. And so first off, what is the slope of the tangent line? Okay, so let's take a look at that first. Okay, so let's go ahead and find that. So let's take a look at line T, which is x plus 2y equals 10. Now, remember the equation for a line is y equals mx plus b, where m is your slope, right? So what we're going to do is we're going to solve for y in this equation, and that's going to help us get the slope. So I'm going to subtract x on both sides here. And so that gives me 2y equals -x plus 10. And then I'm going to divide by 2. And so by doing that, I get y equals -1/2 x plus 5. All right. Remember, there's an invisible 1 just before this x, so I just put that there. And so now we can see that the slope is 1/2, right? So we know that the slope is of this tangent line, which I'll call the slope t, is -1/2, which means that the slope of the radius has to be +2/1. Because since the lines are perpendicular, you have to take the reciprocal of that fraction, meaning you flip it, and then you change the sign. Okay, so these are perpendicular. Okay, so that's something to keep in mind. So now we know the slope of the radius is 2/1, or just 2, basically, which is equal to 2. So now we know the slope of the radius, and so now we can get the equation of the line for the radius. Okay, so if it was like a line, you would be able to get an equation of it. All right, so let's say the equation of R. So let's do that. So to get the equation of R, remember that y is equal to mx plus b, right? And we know the slope is 2, so y equals 2x plus b. And so in order to get the b, I'm going to go ahead and plug in the coordinates that they give us, which is the coordinates of the center. All right, so the center is 2, -1, and so we have x is 2 and y is -1. All right, so I'm going to go ahead and plug in 2, -1 into the equation. So if I do that, then I have y is -1. We have 2 times 2 plus b. All right. And then 2 times 2 is 4. So we got -1 is equal to 4 plus b, and then I'm going to take away 4 on both sides, so that gives me b is -5, which means that the equation is y equals 2x minus 5. All right, so we got the equation of r and we got the equation of t. All right, so let me just underline those. I'm just going to underline those just so that I remember. So now that we got those equations, we know that the point at which they cross here, right, is where the two lines are equal. Okay, so that's an algebra concept. That's not a geometry concept, right? So the algebra concept is if you have two lines where they cross, then they have to be equal to each other, right? So we're going to set them equal. So we're going to set line R equal to line T, okay? So we're going to put that over here. So line R equals line T at the intersection. All right, so we're going to do that here. So since y is equal to 2x minus 5 and y equals -1/2 x plus 5, I'm just going to set those parts equal. I'm going to say -1/2 x plus 5. That equation is equal to this equation, 2x minus 5. And so then we can solve this, okay? So we're going to solve for x here. So I'm going to change this to a -0.5 just to make the math a little bit easier. So I'm going to change this to -0.5x. So that's what I'm going to change it to, okay? And then I'm going to add 0.5x on both sides. That's just to make the math a little easier. And then I'm going to add the 5 to the other side. Okay, so the 5's cancel, the 0.5x's cancel. So what we're left with is 2.5x equals 10 divided by 2.5 on both sides. So x is equal to, actually let me just do it over here. So x is equal to 4. All right, and then what we're going to do is we're going to plug this into this equation, then that'll give us the y value, okay? So y equals 2 times 4 minus 5 equals 8 minus 5, which is 3. So that means the coordinates of the intersection point, the tangent point, so the first tangent point, this is TP for tangent point, is 4, 3. Okay? So now we know that this coordinate is 4, 3, which means if you look at it, that from here to here has to be from 2 to 4, which is 2. And then from -1 to 3 is 4, right? From -1 to 3, 3 minus -1 is 4. Or 4 plus -1 is 3. So that makes sense. You see the slope was 2, right? Because 4 over 2, rise over run, is going to give us 2. So that makes sense. And the second tangent point, so this is the first tangent point, which is given by this equation. The second tangent point is on this side, where this is also the radius, right? Because if I were to draw a line here, if I were to draw a line here, then it would actually be the exact same, it would be parallel, right? They would have the same slope, if that makes sense. And so this point is what I'm looking for my second tangent point. And so in order to find that, that's pretty straightforward, because now you know this, it goes 2 and 4. So that means we're going to go 2 to the left and then 4 down. So 2 to the left, 4 down. And we know the center is 2, -1, right? So the second tangent point So to get the second tangent point, we're going to say, okay, well, the center is 2, -1, but then we're going to subtract 2 to go to the left, and then we're going to go subtract 4 from -1 to go down 4. So the second tangent point is 0, -5. And this is the second tangent point. Okay, so that one's a pretty tough problem. There's a lot of algebra involved in there. There are some geometric concepts, like for example, the radius is perpendicular to the slope, but then after that, a lot of it is just algebra. All right, so number 2, find the coordinates of the centroid of the triangle with the vertices S, T, and R. Okay, so we didn't get a chance to go over too much on this topic. And so this is why I'm going to try to explain this the best I can, okay? So I'm going to take a little time to explain this concept because this is something we didn't get to touch upon in great detail. So when we study triangles, essentially here's the acronym. So I'm just going to give you the acronym that we use. So the acronym that I use is my cousin always owes, and it's a very odd acronym, but it helps me remember. It's a good way to remember. My cousin always owes Anna banana ice cream probably before Christmas. Okay, so very odd acronym, but here's what it does. It tells you so you have MC, AO, AB, IC, PB, and C. And so what these stands for are these. So M stands for the median. C stands for centroid. A stands for altitude. O stands for orthocenter. A stands for angle bisector. Well, AB stands for angle bisector, so I should probably say that. AB is angle bisector. And then IC stands for incenter. And then so PB stands for perpendicular bisector. And then C stands for the circumcenter. Okay, so I'm going to explain this in a little bit of detail. So if I were to have a triangle, the median is a line that goes from the vertex to the opposite edge. Let me just draw this. So let's do median. And then let's do altitude. We'll do angle bisector. Okay, and then we'll do perpendicular bisector. Okay, so the median is a line that goes from the vertex to the opposite side, and it cuts the side in half. So for example, this would be a median. Let me draw the medians in a different color. So this is going to be a median because it's going to cut this in half. From here to here will be a median because it cuts this side in half. And then that's like the midpoint. So from there to there, it's going to cut this in half. So these three lines are known as medians, okay? And the point where they all meet, they always meet at the same point, right? Is called the centroid. Okay? And then the altitude is a line that goes from the vertex to the opposite side at a right angle. So it has to meet at a right angle. It doesn't have to cut the side in half. It just has to be at a right angle. And then from here to like here might be like a right angle. Actually, for this example, the only way that you can meet at a right angle here is if you extend this line and then do like something like that. And that would be like your altitude. Okay. So this one's a little weird because you can't meet at a right angle unless you go outside the triangle, and that's perfectly fine. Sometimes you'd have to do that. But this line here, it just extends this side. And then from here to like probably here would be like a right angle. Okay, so notice that these points all meet. Actually, sorry, that's not a right angle. That's actually less than a right angle. Or yeah, so this would also have to meet on the outside. So let me go ahead and just draw this line out there. And this would have to meet, for this to be at a right angle, it would have to be like something like, here, let me draw this triangle again because it's a little bit hard to tell. I'm going to draw this triangle again. Okay, so for here, it's going to be sort of like that, where it forms a right angle. For here, it's sort of going to be like that, where it forms a right angle. I'm going to extend these lines. And then this is going to meet sort of like this to make a right angle. And you can kind of see I'm making those right angles, but notice that they all meet at a point as well. And that point right there where they meet, which could be outside of the triangle, it does not have to be inside the triangle, is known as the orthocenter. All right. And so that's how I remember is always O's, altitude, orthocenter. And then angle bisector is a line where it cuts the angle in half. So if this is an angle, then it's going to cut that in half, right? So it's going to cut that angle in half. And then it goes to the opposite side. You have this angle here, which is going to get cut in half. And then you have this angle here, which is also going to get cut in half. But notice that they all meet at a point as well. And this point always is inside the triangle. This point is never outside of the triangle because it is known as the incenter, meaning it's actually inside. All right. And now the incenter is an important point because it actually helps you draw a circle inside the triangle. So it actually gives you a circle that is inscribed. So this is an inscribed circle. That's why it's called an incenter. Okay, so it's very important. And then perpendicular bisector is, you know, we talked about perpendicular bisector. It cuts the side in half and at a right angle. So here, this is cutting this in half and it's at a right angle. I'm just going to draw the line, and this line can extend, right? It doesn't have to stay there. And then we have cutting, we're going to cut this in half, roughly is like around here, and then at a right angle. And then we're going to cut this line in half. Let me say, I forgot to, oh wait, that's not in half. Hold on a second. That is not half. Well, I guess it's around there. Yeah, so that's around there. And then, so I'll just draw these lines out there. Okay, and then we're gonna do this one, which is gonna cut this in half and then at a right angle. But notice that they all meet at the same point right there. And that point is known as the circumcenter. And that does not have to be located inside the triangle. It sometimes is. Sometimes it's on the triangle. Sometimes it's outside the triangle. It just depends what kind of triangle it is. But the circumcenter makes a circle as well. And the radius of that circle is basically the distance from the vertices of the triangle to that center. So that's your radius to that circumcenter. So these are all actually the same distance, if you notice. And then, so this circle, if I were to draw it, would be a circle that is circumscribed. That's why it's called a circumcenter. It makes a circumscribed circle. All right, so that's a lot of detail. I just wanted to educate you on that, on the different types. And so we're going to be using the median here. It says find the coordinates of the centroid. So centroid means median, right? We're using medians, I'm saying. So we're going to be use the median with the vertices. Okay, so this is going to be fairly involved. Let's go ahead and do this. I'm going to try to show you the best I can with the limited space here. So we're going to try to draw the triangle first. Okay, so we got the vertices are 2 and 5. So we got S. We got T, which is 6, 5. We got R, which is 10, 0. All right, so we got ourselves a triangle. And so what we need to do is we need to figure out, we need to basically essentially draw the medians, and we need to, in order to do the medians, we need to know the midpoints. Okay, so what I'm going to do is I'm going to need to figure out the midpoints where the middle is for each of these. Okay, so that's what I'm going to try to do, but I'm only going to do it for 2 of them, because as long as you do 2 of them, you should be able to get the answer, and you don't have to do all 3. Okay, so that's the good thing. I didn't mean to erase all that, so I apologize. All right, so let's go ahead and do the midpoint then. The midpoint is the middle, right? So midpoint formula, I'll write over here just in case you forget it. x1 plus x2 divided by 2, y1 plus y2 divided by 2. All right, so let's go ahead and do the midpoint for RS. So for RS, the midpoint is going to be, well, the coordinates for R. So 10 plus 2, right? So 10 plus 2, add the x's together, divide by 2. Add the y's together, the y coordinate for R is 0. 0 plus 5 divided by 2. And by doing that, you get 12 divided by 2, which is 6, and then 5 divided by 2, which is 2.5. And let's get the midpoint for ST. Let's do ST. So we'll do RS and ST. So ST, 2 plus 6 divided by 2, and then 5 plus 5 divided by 2. So it's going to be 8 divided by 2, which is 4, and then 10 divided by 2, which is 5. All right, so we got 6. So for RS, we got 6 and then 2.5. Okay, so that's that point there. And then for ST, we got 4 and then 5, which is this point there. Okay, so we got the midpoint. So now we're going to basically, I'm going to draw the median. So that's going to be from there to there. And then for this, it's going to be from here to here. So we got to figure out the coordinates of this, that's the centroid, okay? So that's the centroid right there. All right, so let me put the green is the centroid. All right, so we're gonna try to figure out those coordinates. Now, in order to do that, we need to write the equation of each line. All right, so let's write the equation of line T. I'm gonna call this line T. So line T. And then I'm going to call this other one, I'm going to call it line well, yeah, I can call it line RS, right? Or I'm going to call it line R. Okay, so for the equation of line T, notice that it's going up and down. It's completely vertical, which means that the equation is x equals a number. Remember, if x equals a number, the line just goes up and down like that. So in this case, x is equal to 6, because notice that 6, it's going down to the 6. So x equals 6. That's what the equation of that line is. All right, the equation of line R is, well, we have to basically use y equals mx plus b, right? So remember, the equation of a line is y equals mx plus b. That's the slope-intercept form, right? So we need to figure out what the slope is. The slope is rise over run. So let's go ahead and do the rise over run here. I don't know what's going on here. It's changing the colors. See if I can get rid of that. All right, so let's do the slope, rise over run. So it goes, let's go rise. Oops, rise is going down. Looks like it's going down 5. So -5. And it's going over 1, 2, 3, 4, 5, 6. So it's going over 6. So the slope is -5 over 6, right? Okay, so let's write that here. The slope is -5 over 6. Okay, so for that red line, for line R. All right, so we got y equals -5 over 6 mx, right? M is -5 over 6. So mx plus b. Now we don't know what b is, so we're going to need to find it. We're going to do that now. So let's go ahead and use point R, because we know point R is 10, 0. So let's plug in 10, 0 into that equation. So x is 10 and y is 0, right? So let's plug in 0 equals -5 over 6 times 10. I just picked any point. You can pick any point on line R, but is obviously we're just going to use R. And then plus b. So 5 times, so basically -5 times 10 is -50. So we get -50 over 6 plus b. And what I'm going to do is I'm going to add 50 over 6 to both sides. And so that's going to give me my b. Okay, so that means that b equals, let me just write it over here. So b equals 50 over 6, which is 50 over 6. That is the same thing as, let's go ahead and reduce that. So we can divide top and bottom by 2. So it's 25 thirds. Okay. Actually, let's leave it as 50 over 6. Should we leave it as 50 over 6? Yeah, let's leave it as 50 over 6 instead of reducing it. All right, so the equation is -5 over 6x plus 50 over 6. All right, so now we got our b. So now what we're going to do is we're going to set these equations equal to each other, because we know that any two lines that cross, the equations must be equal. So we're going to say line T equals line R. So now we can set these equal. So we got, so basically what we're going to say, we're going to set them equal, which means that x equals 6. So basically we're just plugging that into there. That's essentially what we're doing. So we get y equals -5 over 6 times 6. We plug in that x in there now, because the equations are equal. So that means the x's are equal. And then, so notice that these cross out. These cancel, so leaving you with -5. So we get -5 plus 50 over 6. Which I guess I should reduce this now. So -5 plus, let's go ahead and reduce it, divide by 2. So I guess I should have reduced it after all, but it's all right. So 25 over 3. So let's put this over an invisible 1. All right. Actually, here I'm gonna make this a little bit easier, but I should have left the 6 down there, but let's just go ahead and do this. So we need a common denominator, so I'm gonna multiply this by 3. So this will be negative 15 over 3 plus 25 over 3. And then add the numerators. 25 minus 15 is 10. So it's gonna be 10 thirds. So y is equal to 10 thirds. So now we know where they cross. So the centroid has to be 6 and then 10 thirds because x is 6 and y is 10 thirds. Now we got our final answer. Okay, so that was fairly involved. There are a lot of concepts involved in that problem. Very loaded, which is why I wanted to take time to kind of explain that. All right, so number 3 we have talked about before, but it was in the beginning of the year. So so you may or may not have forgotten it. So it says point A has coordinates negative 5, 3. If this point is 3/4 of the way from A to B, what are the coordinates of B? All right, so I'm going to go ahead and just draw this real quick. So we get the idea. That's point A, negative 5 and 3. The point 1, 1, 6 is here. We'll call that point C. And then B, okay, so if the point 1, 6 is 3/4 of the way from A to B, so we don't know where B is question mark, okay? The coordinates of B are unknown at this point. What are the coordinates of point B? So basically we have a line from A to B, and this here is 3/4 of the way from A to B. So that's 3/4 of the distance. All right, so what we're gonna do is we're going to find the rise of a run here. Yeah, so let's go ahead and call this, I'm gonna color code here. Let's call this dx, and this is the distance in the x direction from A to B. And then we'll call this distance dy, which is the distance from A to B in the y direction. And we're trying to figure out what that is because we don't know what that is. And that'll help us find the coordinates of B. And let's do the rise and run from A to C, shall we? So for here, from A to C, it's a distance of, well, we know what's the distance from negative 5 to 1? Well, that's going to be 6. So if you just count the number of spaces from negative 5 to 1, that's 6. And then let's do the rise from A to C. Well, C is at 6 and A is at 3, so that's a rise of 3. Okay, so now what we're going to do is we're going to say, all right, so we know that 6 is 3/4 of the way from A to B, right? 6 is 3/4 of the way, and so is 3. So 6 is 3/4 of the way of the distance in the x direction. In the same manner, in the same way, 3 is 3/4 of the distance from A to B in the y direction. So we're going to say 3/4 of dy. Okay, and then we're going to solve. So let's go ahead and solve this. So basically, in order to do this, you got to multiply by the reciprocal on both sides. So let's multiply by the reciprocal. Okay, so then we can get dx. So dx is equal to, let's just do this on the right side. So 4 times 6 is 24. 24 divided by 3 is 8. All right, and then 4 times 3 is 12. 12 divided by 3 is 2. So we get dy equals 12 over 3, which is 4. Okay, and so that's saying now that this is 8 and this is 4. So now we can get the coordinates of B. To get the coordinates of B, we got to go from A, and then we're going to go 8 to the right and 4 up, okay? And that'll be our final answer. So the coordinates of A are -5 and 3. So we got to go -5 plus 8. And then 3 plus 4 in the y direction. And that will give us our coordinates. So the final coordinates of B are 3, 7. All right. So there's a lot that goes on to these problems. So you need to draw pictures so that you can kind of visualize what's going on. All right. Pictures are immensely helpful, especially in geometry. All right, number 4. What are the coordinates of the point 4/5 of the way from D to E? Here they have the picture, so it makes it a little easy. Keep in mind that these are going by 2s. 2, 4, 6, 8. 2, 4, 6, 8. These are going by 2s, so be very careful when you're counting stuff. All right, so we want something to be 4/5 of the way. So we need to figure out, okay, well, how far is it from A to B in the x direction, and how far is it in the y direction? So in the x direction is 2, 4, 6, 8, 10. Remember, these are going by 2s, so there's 5 spaces, but each is worth 2. And then in the y direction is 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. So they're both 10. All right, and then what we're going to do is we're going to go 4/5 of the way. So we're going to multiply this by 4/5. Okay? And so by doing that, we get 40 divided by 5. 10 times 4 is 40, which is 8. And this is also 8. So that's saying is we need to go 8 to the right. 2, 4, 6, 8, and then 8 up. 2, 4, 6, 8. And that will take us there. So 8 and 8. That will take us to the point that they want us to find. All right, and so the coordinates of that point are 4 and 4. And that's our answer. All right, a city map is placed on a coordinate grid. The post office is located at the point 535, the library is located at that point L, and the fire station is located at F. What is the ratio of the length of PF to the length of LF? Okay, so we're just gonna draw this out. And I'm going to go by 5s on the y-axis. And the reason being is that we want to make sure that we have enough space on the paper because there's some big coordinates for the y. So 5 and 35, that's P. That's the post office. Library is located at 9... or 15, yeah, 1510. And the fire station is between them, is 925. Okay, so the fire station is between those two. And what we need to do is figure out the rise and run. So let's go ahead and do the rise and run. So how much does it go down and over? So here it looks like it goes down 10 from 35 to 25, and it goes over 4 from 5 to 9. Then from here to here, it goes, let me use a different color, here to here. It goes down from 25 to 10, that's 15. And then from 9 to 15, that's 6. And so we want to get the ratio of the length of PF to the length of LF. So we don't have to use all these coordinates. We only have to use either the x or the y. So we could say, okay, well, we want to go from PF to LF, right? So we can use the 4 and the 6 to do that. We could say, okay, it's a 4 to 6 ratio in the x direction, right? Or we could say it's 10 to 6 or 10 to 15 in the y direction. But either way, you're going to get the same answer. 4 to 6 reduces to 2 to 3. And if I divide by 2, that is. And this, if I divide by 5, gives me the same answer, 2 to 3 ratio. So either way, it's a 2 to 3 ratio from PF to LF. All right. So let's take a look at the next page. Use coordinate geometry to solve involving perimeter or area. All right, so we want to figure out the area of this park. Now, here's the trick for this type of problem. If you see a coordinate problem with a triangle and they want you to find the area and it looks kind of complex, because remember, the area of a triangle is 1/2 base times height. And so what you need to do is you need to find, okay, this is the base, for example, but I need the heights to be perpendicular. So the height has to be at a right angle. Now, I don't know if that's a right angle or not, right? I can figure out whether it's a right angle, and we could do that if we want. Okay, so in order to figure out whether that's a right angle or not, so let's do that. We need to figure out the slopes. Okay, so let's do the rise and run. So we got 1, 2, 3, 4, 1, 2. Okay, so that's rise over. So that means the slope here is 2/4, right? Rise or run, and then we're gonna do the same thing here. 1, 2, 3, 4, 1, 2. So it goes 2 to the right and 4 down. So the slope here, we'll call it slope 1 and we'll call it slope 2, is rise over run. So that means it's so now notice that because these are reciprocals and they switch signs, they must be perpendicular. Which means that this is a right angle, okay? So you can do that in order to determine whether that's a right angle or not, okay? However, I'm gonna show you a different way. I'm gonna show you an easy way to deal with these problems because finding the length of all of these can be kind of a pain, okay? So I'm gonna still keep these marks here, by the way. All right, so what I'm gonna do is I'm gonna make a rectangle out of this entire thing. You see this rectangle with the blue, red, and green parts? That's what I'm gonna try to do. This is 2, and this is 1, 2, 3, 4, 5, 6. Okay, and we can ignore the negatives. Let's just make all the numbers positive. It doesn't matter if it's negative in this case. So we'll just call this 4 instead of -4 because we're looking at distance, not slope. All right, so we're gonna call this triangle 1, 2, 3, and then we're gonna call this triangle 4. Okay, so the area for triangle 1, first off, we need to remember that the area of a rectangle is base times height. Okay. All right. So because we have this big rectangle. All right. So the area of triangle 1 is 1/2 base times height. Well, we already know this is a right angle, so we got base is 2 and height is 6. So 1/2 of 2 is 1. 1 times 6 is 6. So the area of the green triangle is 6. Let's do the area of the blue triangle, which is area, we'll call it, that's 2. And then it's going to be 1/2 base times height, 2 times 4. 1/2 of 2 is 1, so this is 4. And then the red triangle, A3, 1/2, and then the base is 4, the height is 2. 1/2 of 4 is 2, 2 times 2 is 4. All right, and then we don't know the area of the triangle 4, that's what we're trying to find. So to get the area of triangle 4, I need to get the area of the entire rectangle minus the other triangles. So if I add up the green, blue, and red triangle, and I subtract it from the rectangle, that's going to give me the rest of it, right? So I'm going to add the green plus the blue plus the red triangles. And then we can subtract it from the rectangle, and then we can get the one that we actually want. So let's get the area of the rectangle. So the area of the rectangle is base times height. The base of the rectangle is 4, this is the base, right? And the height of the rectangle is 6, so it's 4 times 6. So it's 24. So we're going to do 24 minus, and then we're going to add these other ones, 6 plus 4 plus 4. So 6 plus 4 is 10, 10 plus 4 is 14, so 24 minus 14. That means the area of the triangle that we're looking for is actually 10. And that's how we get that. So that's the quick way of doing it. I know it doesn't look quick, but when you actually do it, you can actually do it pretty quickly. All right, and that means that you don't have to use the distance formula and all that stuff in order to get like the base and the height and all that. All right, so number 2, we're gonna look at a problem like that. Actually, let's skip to number 4 real quick, and then I'll go back to 2 and 3 because this is a similar type of problem. What is the area of the triangle? So again, just to kind of show you what we were doing before, we basically made this into a rectangle. So you want to basically make right triangles out of this. Okay, and that's how we do it. In this case, we have, we're going to call this triangle 1, triangle 2, and then we'll call this triangle 3. All right, so, and then again, so let's go ahead and get triangle 1. So 1, 2, 3, 4, 5, 6, 7, 8. This is 8. This is 9. And then and this is 8. And this is 3. Is it 3? It might be 3. Yeah. It's 3. Okay, so area 1 is 1/2, base is 8, height is 9, so base times height. Half of 8 is 4, 4 times 9 is 36. Let's do the green triangle. Area 2, 1/2, base is 8, height is 3. So you have 4 times 3 is 12. And then we need to do the area of the rectangle, which is the entire rectangle, which is it's the base is 8 and then the height is 9, right? So 8 times 9 is 72. Okay, so area 3 is equal to the area of the rectangle minus, and then add area 1 plus area 2. So area of the rectangle is 72 minus, and then we got to do 36 plus 12. So 72 minus 48, which is equal to 24. All right, and that's the area of that triangle. So that's how you deal with those kind of coordinate problems with triangles, because finding the right angles and all that for this kind of triangle is a pain in the butt. So easier to just do it that way. All right, so let's go back to number 2 as promised. 2 of the vertices of a triangle are given. Which coordinates of the third vertex will make the area of the triangle equal to 16? So again, it's good to visualize this. 0, 1 is over here. We'll call that point A. We'll call this point B. So we got 0, 1, we got 1, 2, 3, 4, and then we got 1. Okay, so that's B. And we want to figure out where the third vertex is going to be, so we don't know where it is yet. Now remember, area of a triangle is 1/2 base times height. Well, right now we got our base. Our base is, we'll call that the base. And then, so that is a distance of 4, right? So we have 1/2 times 4 times h. And we want the area to be 16, right? So we got 16 is my area. Half of 4 is 2, so that means we got 2h. So that means h has to be 8, right? So h has to be equal to 8. The height has to be 8. So wherever this point C has to be 8 away from B or from A, right? So it could potentially be 8 away from B. So let's do that. Right now their height is 1. So 8 away would be at the 9, right? 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 8 away. So it could be over here, right? Potentially it could be at the coordinate 1, 2, 3, 4, 4, 9. That's a possibility. So here are the possibilities. So let's list all the possibilities. Because if it's up here, then the height is 9. 9 times 4 is 36. 36 divided by 2 is, 8. So if it's here, it's going to be 8, sorry. 8 times 4 is 32. 32 divided by 2 is 16, which is the area. So 4 is 9. 4, 9 is possibility. It could also be 8 down. It's possible it can go down. So 1, 2, 3, 4, 5, 6, 7, 8. So this will be a -7. If it's 8 away from 1, right, then it's going to be there. So it could potentially be here as well. And then you can make this triangle. And that coordinate is 4, -7. It doesn't have to be above B or below B. It could be above A, in which case it would be over here, which is 0, 9. And then you would have to make this triangle, right? And then finally, it could be down here, in which case you would make this triangle, which is 0, -7. So those are our possibilities. 0, -7, 4, -7, 0, 9. So those are our possibilities, but there's only one answer here that they give us. So let's see. They give us 4, -7, so we're going to choose that as our answer. All right. So number 3, the endpoints. Okay, so the endpoints of one side of a regular pentagon are -1, 4, and 2, 3. What is the perimeter of the pentagon? All right, so a regular means that the sides are all the same length, okay? So it's a regular pentagon. All the sides are the same length here. So, and they said that the one of the ends was -1. So this is -1, 4, and this is 2, 3. That's one of the sides of that pentagon. Now, to get the distance of this, you got to use the distance formula, right? So we got to use the distance formula, which is square root x2 minus x1 squared, y2 minus y1 squared. Okay. So just subtract the x's, subtract the y's. -1 minus 2 squared, and then 4 minus 3 squared. That's how you get the length of that. Equals square root. Now -1 minus 2 is -3. 4 minus 3 is 1. So you got to square them. So 3 times 3 squared is 9. 1 squared is 1. So we get 9 plus 1 is 10. So the length of this is square root of 10. But because this is all because it's regular, all of these are square root of 10, right? So basically we could just add all of them up. So in the end, you just take the square root of 10 and you multiply by 5. The perimeter is 5 times the square root of 10. Because there's 5 of them. Square root of 10 plus square root of 10 plus square root of 10. That's 5 square root of 10. So the answer is B. All right. Let's go ahead and do the next one. This one is 2 standards in 1 page, I believe. So yeah, it says those 2 benchmarks. So let's take a look at that. Identify shapes of 2-dimensional cross sections. Identify 3-dimensional objects generated by rotations. All right, so this is a topic that we didn't get into much detail on. So I do want to, it's good that we're going over it. All right, so by the way, this should say parallelogram, not rectangle. So that's a typo there that you want to fix. All right, so a plane intersects the regular octahedron shown through its top and bottom vertices. Which best describes a cross-section? Okay, so this is the top and then this is the bottom, right? So we want a plane. A plane is a flat surface, so like a flat rectangle, for instance. So this is, let's call this the plane. So imagine that this plane was a knife, the blade of the knife, and it's cutting this through the top and the bottom. Well, if it cuts this through the top and the bottom, then it's going to make a cross section. Let's use a different color. That's going to have this shape. Hopefully y'all agree that this is what the shape is going to be right there. Okay. And that is a parallelogram, right? So that's not a triangle. It's not a trapezoid. It's not a hexagon. So that's going to be a parallelogram. It's not going to be a rectangle because if you look at this example, we don't necessarily know what this distance is. So if these distances were the same, like this and this, then it would be then it would definitely be a rectangle, but we don't know that it's the same. Okay, so so we'll just say that it's a parallelogram. All right. So what I'm trying to say, if this is H, then this is H. So this is the same here. This is the same here and here, but we don't know that the diagonals are not necessarily the same. Okay, so we'll say parallelogram or rhombus. It might actually, yeah, it looks like it might be. This is actually a rhombus, right? Parallelogram or rhombus. All right. Okay, so for number 2, it says a rectangle is rotated about one of its sides. What three-dimensional figure is formed? Okay, so let's say we have a rectangle. We want to rotate it about one of its sides. So basically, if we were to have an axis here, like like an axis, and we rotate it around there, what shape is going to be made? Well, if I rotate this around, then it's gonna be rotated like this, like this, like this, like this, like this, like this, and it just keeps going, right? So hopefully y'all can kind of see what I'm trying to make here. And so when I do that, if I do this everywhere, then what shape is it going to make? What solid is it going to make? It's going to make a cylinder. You all see that? So it's going to make a cylinder if I rotate that. So that is a cylinder. Okay, so let's take a look at another one of that. Choose the space figure formed by rotating each solid about the axis of rotation. So if I were to rotate this sector about this axis like that, then it's going to go like this, right? This is going to go like this, and this is going to stay there. This is going to go like this, and you can kind of see it makes like a bowl, right? A bowl shape, and that's a hemisphere. A hemisphere is half of a sphere. Okay, now take this triangle, and if I rotate it, then notice it's going to make a cone-like shape, right? And so that's what it does. It makes a cone. All right, and then it doesn't matter if I rotate this around the middle instead of the side, it's still going to make a cylinder, right? It's just going to be a lot of different, things, which are kind of hard to visualize. Very hard to visualize. But it's still going to make like a cylinder shape, right? So if I rotate this, it's going to go like this. If I rotate this, it's going to go like this. If I rotate this, it's going to go like this, right? And you can see it forms all these circles, but then this is going to stay vertical. So it makes your cylinder. All right. So let's do number 4. Select all the polygons that can be formed by the intersection of a plane and a cube. So let's draw a cube. Okay, so if we were to draw a plane like this, then it would just make a square, right? All right, so if I do that, it makes a square. I could also cut it, for example, here, where it kind of cuts through these. And if it cuts through that, then it's going to make a rectangle. You can kind of see that it makes that little rectangle. So I can cut it that way and it would make a rectangle. So those are the only shapes. You can't really get a pentagon, hexagon out of this because there's only 4 sides that we have and when we cut it. And then can't really make a triangle by cutting it with a plane. So we're just gonna leave it at that, square rectangle. All right, number 5. What shape is the cross section formed by the intersection of a cone and plane parallel to the base of the cone? What shape is the cross section? So if we have a cone, and then we want a plane parallel to the base of the cone. So this is the base of the cone, right? So if I cut it with a plane that is parallel to that, well, then what's the shape going to be? Well, the shape is going to be, if I slice it that way, right, I'm going to get a circle. If I slice it and I stare down at it, it's going to, that shape there is going to be a circle. So that's going to be A. Now, if I were to take a cone and I were to slice perpendicular to the base, so this is parallel to the base, right? If I were to slice perpendicular to the base, then that means it's going to be a something that cuts like this, right? Perpendicular, where it's a 90-degree angle. And so if I were to do that, well, if I were to slice down this way, well, then I'm going to get a triangular cross section. Can y'all, hopefully y'all can see that. It's not going to look like that though. It's going to, if I were to slice perpendicular, then I would get this triangular part right here. Sorry, it'd be this triangular part. Okay. Or I could also cut it perpendicular this way, because that would also be a right angle, and I would get this triangular part. So perpendicular for a cone is going to be a triangle essentially, and then parallel is going to be a circle at the end of the day. Which figure can have the same cross section as a sphere? So remember, if you have a sphere and you slice it with a plane, then you're going to get a circle, right? So we need the cross section to be a circle. If I slice this with a plane, I'm going to get a rectangular cross section. If I slice this parallel, I'm going to get a trapezoid cross section. Hopefully y'all can see that. If I slice this here, I'm going to get a rectangular cross section if I slice it that way, or if I slice it the other way, I would get a trapezoid, depending on what direction you sliced it. If you sliced it parallel or perpendicular to the base. But then if I slice it here, then I could get a circle, right? So that's going to be B. All right, number 7. Erin drew a 3-dimensional figure with an interesting plane to show a circular cross section. She then noticed that all cross sections parallel to the one she drew would also be circles. What additional information will allow you to conclude that Erin's figure was a cylinder? All right, so to conclude that it's a cylinder, first off, if you have a cylinder, we know she said that the cross sections parallel would be circles, right? So if I were to, so basically what we're saying is that if I were to slice it there, I get a circle. If I were to slice it another way parallel, I would also get a circle. And notice that if I keep slicing it, I get a bunch of circles. If I keep making slices parallel to this, I'm going to get a bunch of circles. And these circles are congruent, right? They're the same shape. Now, if I do that with a cone, they're not going to be, right? Because if I slice it this way, I get a big circle. If I slice it this way, I get the same shape, but I get a smaller circle. So the circles are not congruent here. All right, so in order to conclude that it's a cylinder, we need to know that the circular cross sections, no, not similar. So in a cone, the circles are similar. In a cylinder, the circles are congruent. So the answer is B. Okay, so let's go ahead and do, okay, so we're gonna go ahead and end the video here, guys, just to keep it an hour length. I know there's gonna be multiple parts, but if I can keep it to within an hour or so, then that would be great. All right, guys, that's gonna do it for the video. We hope you learned something. As usual, I'll see you in the next one.